Hello, it's Brian Howard again, and welcome back. This presentation is on assessing student learning in cybersecurity curriculum. Now, this will prepare you for the hands-on activity on assessment design in Module C. You're going to explore effective strategies for evaluating both technical skills and conceptual understanding in cybersecurity education. Now, this presentation, like I said, builds from the previous work with backward design and standards mapping. But today, we're going to focus specifically on how to assess student learning in cybersecurity contexts, addressing both the technical and the conceptual dimension of cybersecurity education. Now, these strategies we'll explore will directly support your work in the upcoming asynchronous activity. Now, cybersecurity education presents unique assessment challenges. The field evolves rapidly, requiring assessment that remain relevant despite changing threats and technologies. We must evaluate both hands-on technical skills and deeper conceptual understanding. Real-world application is essential, but classroom constraints can make authentic scenarios difficult to create. Additionally, developing a security mindset, thinking like both defender and attacker, requires specialized assessment approaches. And these challenges mean traditional assessment methods can often fall short in cybersecurity education. Let's situate assessment within our backward design framework again. After identifying desired results, through standards and learning objectives, we determine what evidence demonstrates the students have achieved those results. This is where assessment comes in. Assessment serves as the bridge between our desired outcomes and the learning experience we design. Effective assessment in cybersecurity must align directly with standards while providing meaningful evidence of both skills and understanding. Now, cybersecurity competence has a dual nature. Technical skills represent what students can do, the hands-on abilities to configure systems, identify vulnerabilities, and use security tools. Conceptual understanding represents what students know, the principles, models, and frameworks that inform security decisions. Effective assessment must address both dimensions. For example, students might demonstrate technical skill by configuring a firewall, but conceptual understanding by explaining why specific rules were implemented based on defense and in-depth principles. Now, assessment serves multiple purposes in cybersecurity education. Formative assessments provide ongoing feedback during instruction, helping adjust teacher strategies and identify misconceptions. Summative assessments evaluate achievement at the end of a unit or course. And then we have diagnostic assessments, identify technical readiness and background knowledge, critical in classes with diverse technical experience. Skill verification confirms mastery of specific technical abilities, and assessment data can also support a program evaluation and help align curriculum with industry needs and certification requirements. Now, performance-based assessment requires students to demonstrate skills by performing authentic tasks. Now, in cybersecurity, this might include conducting a network security audit or configuring a system according to security standards, responding to simulated incidents, or performing ethical hacking in a controlled environment. These assessments directly measure technical skills and typically engage students in high levels. However, they can be resource intensive and produce technical setup challenges. When designing performance assessments, focus on realistic scenario and clear evaluation criteria. Now, project assessment involves students creating artifacts that demonstrate understanding over time. Now, examples include developing comprehensive security plans, conducting threat modeling projects, creating security awareness campaigns, or developing security policies. Projects integrate multiple skills and concepts, allow for depth of exploration, and support collaboration. However, they require significant time and can be complex to evaluate fairly, and may disadvantage students with limited resources or support outside the classroom. Effective project assessments include clear milestones, specific evaluation criteria, and structured support. Now, scenario-based assessment presents students with realistic cybersecurity situations to analyze and respond to. Examples include analyzing security breaches, conducting risk assessments for fictional organizations, navigating ethical dilemmas, or evaluating security architectures. These assessments promote contextual application of knowledge and critical thinking. They can be adapted in complexity for different student levels. Challenges include creating realistic yet accessible scenarios and balancing the level of detail provided. Effective scenario assessment include clear context, specific questions or tasks, and explicit evaluation criteria. Now, traditional assessments approaches like quizzes, tests, written responses still have a place in cybersecurity education. They efficiently assess knowledge of security principles, technical terminology, and understanding of protocols and standards. These formats are familiar to students and relatively easy to administer. However, they may not reflect real-world application of knowledge and have limited ability to assess technical skills. When using traditional assessments, focus on higher-order thinking questions, include scenario elements when possible, and ensure alignment with both technical and conceptual learning objectives. Now, industry-aligned assessments models tasks after certification exams and industry practices, and many examples include certification-style practice questions, skill verification tasks based on industry standards, professional portfolio development, and mock interviews. These assessments directly prepare students for careers, often increase motivation, and ensure industry relevance. Limitations include the rapid evolution of industry needs and the potential tension between certification preparation and the broader educational goals. When designing industry-aligned assessments, balance specific certification preparation with broader cybersecurity principles and ensure alignment with the educational standards. Now, effective cybersecurity assessment follow key design principles. Alignment ensures direct connection to standards and learning objectives. Authenticity reflects real-world cybersecurity contexts and practices. Clarity provides students with explicit expectations and success criteria. Accessibility accommodates diverse learner needs and technical backgrounds. Now, security considerations address the ethical and security implications of assessment activities. And finally, effective assessments generate actionable feedback for both students and instructors. So when designing assessments, use these principles as the checklist to ensure quality and effectiveness. Creating effective assessment items require attention to several characteristic items. They should be clearly written, technically accurate, and focus on specific learning objectives. They should present appropriate difficult levels and be free from bias and accessibility barriers. Whenever possible, include realistic context to enhance relevance. Notice how the example transforms a vague, decontextualized prompt into a specific contextualized task. That requires both technical knowledge and application. When creating assessment items, consider what specific evidence of learning you're seeking and design prompts that directly elicit that evidence. Rubrics are essential tools for evaluating cybersecurity performance. Effective rubrics include, key performance dimensions and typically performance levels with clear descriptors for each dimension at each level. For example, a network security assessment might evaluate technical accuracy, thoroughness of security controls, quality of documentation, risk analysis, and standard adherence. When developing rubrics, use specific observable language, focus on quality rather than quantity, and avoid subjective terms like good or poor. Test your rubric with simple and work to ensure clarity and usability from implementation. Authentic assessment in cybersecurity connects classroom evaluation to real-world practice. Strategies include using standard tools, incorporating actual security incidents in case studies, designing realistic scenarios, including practical constraints involving industry professionals and simulating organizational contexts. For example, rather than a generic vulnerability assessment, create a scenario where students must identify vulnerabilities in a specific system with defined constraints, stakeholders, and compliance requirements. When designing authentic assessments, balance realism with educational scaffolding and ensure alignment with learning objectives. Technical considerations are particularly important for cybersecurity assessment. Environment options include local virtual machines, cloud-based labs, simulation platforms, and containerized environments. Each has benefits and limitations regarding accessibility, cost, and realism. Security considerations include proper isolation of the assessment environments, clear ethical boundaries for security testing, data, privacy and student submissions, and safe practice of offensive security techniques. When planning assessments, consider technical requirements early, have contingency plans for technical issues, and ensure all activities follow ethical guidelines and institutional policies. Differentiation is crucial in cybersecurity education due to varying in technical backgrounds. For students with limited technical experience, provide glossaries, structured templates, scaffolding instruction, and focus on building conceptual understanding alongside basic skills. For advanced students, offer extension challenges, opportunities for deeper exploration, leadership roles and group work, and connections to advanced industry applications. Effective differentiation maintains high expectations for all students while providing appropriate support and challenge. Consider each tiered assessment with core requirements for all students and optional advanced options. Effective feedback in cybersecurity assessment includes specific comments on technical implementation, thought-provoking questions, suggestions for alternatives, connections to industry practices, and a balance of strengths and areas of improvement. Grading considerations include how to weight technical versus conceptual concepts, how to assess individual contributions to a group work, and how to evaluate both process and product, and how to balance a formative and summative assessment. When developing feedback approaches, focus on actionable guidance that support improvements and help students connect their work to professional practice. Assessments should be integrated across cybersecurity curriculum rather than treated as an isolated component. Connect assessment directly to the standards mapping work from previous activities to ensure alignment. Design assessments that complement hands-on labs and other learning experiences. Build a coherent progression of assessment approaches that develop skills and understanding over time. And consider how individual assessments contribute to program-level evaluation. Finally, use assessment data systemically for continuous improvement of curriculum instruction. Now, let's prepare for your upcoming asynchronous activity on the assessment design. You apply the concepts from this presentation and select assessment strategy. You design a specific assessment items, rubrics, and plan for implementation. And you have access to the templates and some other resources. And you will submit this in your activity workbook for this Module C. So I look forward to seeing what your assessment approach is in cybersecurity, and have a great day.